and I am sharing the screen. Okay. So in this, can you visible? Is it visible to you? Assignment 1. Can you see the screen?
Yes, sir.
So if you have any doubt in any question, there are a total 8 questions. Okay, so if you have any doubt in any question, you can ask. You could clear your doubts. He will explain you about the solution. Okay, or in short, he can tell you the procedure how you can solve. And one more thing, I have checked your solution, means uploaded solution of assignment 1 for question number 2. For this question number 2, many of you have given the solution based on your 11th 12th JEE exam preparation. Okay, and this question was intentionally given to you to apply a star delta conversion or delta star conversion. Okay, so you can although you have received your correct answer, but you have to verify your answer using star delta process, right? A star delta conversion process. Okay, so that you will be confident in that applying star delta or delta star conversion process. Clear? Is it clear to you?
Yes, sir.
Okay.
Yes, sir.
Okay. So if you have any doubt in this assignment 1 or tutorial 1 that we have given, tutorial is also open here. So if you have any doubt in this tutorial also, there are total 8 questions we have given. So if you have doubt, you can ask. In assignment or tutorial?
The question 5 of assignment first.
Assignment first, question 5. Okay.
Yeah.
So what is the doubt?
Sir, corner potentials.
Corner potentials.
So what method are you using to actually test out the potentials? Are you doing this using some KCL or you are making notes?
You can call him sir, okay, because he is your super senior. Okay. So you can ask your doubt, means regarding the corner potential, VA, VB, VC, VA, VC, VD and VE. You have to find out, right?
Yes, because the question here is very simple and most of the things are already given here. It's one single loop. I hope everyone knows difference between loop and a mesh. Yes, sir. So what's the difference between loop and a mesh, Apur? Apur? That's all right. You don't need to Google it. Okay. I can also answer.
Pranjal,
सर लूप सर्किट का कोई भी वो पार्ट होता है जिसमें अगर छोटे लूप जो है उसमें और आ सकते हैं लाइक और मैश वो होता है जो सबसे छोटा लूप होता है उसके अंदर और कोई लूप्स आ नहीं सकते.
Okay, yeah, right. So difference between loop and a mesh is that what is a loop? It's if you start from circuit anywhere and you just iterate through several elements and you just come back to that similar point, then that whole path covered by you is called a loop. And a loop can also have another loop inside of it. Okay. But what is a mesh is that mesh is a special type of loop which do not contain any type of what we say loop inside of it. It's a smallest possible loop. Here what you are given is actually a mesh, right? Because here in A, B, C, D, E, we cannot actually find any other thing, right? we cannot break it down to another smaller loop. So most of you are very, I think, comfortable with electronics, right? I want some sort of trivia right now, okay, before starting the tutorial session. Since all of you are here, how many of you are actually interested in electronics, and how many of you were just allowed to do electronics because your rank wasn't enough or you wanted CS? Okay, okay, nice. So, what I actually want is all of you to be actually interested in electronics, right? Because electronics is some sort of a subject which, if you just read it as a burden, right? कि चलो अब मिल गई इलेक्ट्रॉनिक्स तो कर लेते हैं कुछ एक अब मजबूरी है तो it will be something that that doesn't actually resonate with you. Electronics is actually basically just physics, right? All of you would be very interested in physics in, I think, your JE preparation. Physics also was my favorite actually subject, right? And electronics is just something which is based upon physics, right? It starts from physics, takes on mathematics as its tool, and just go on from there. And I think if I just break down electronics as a subject for you, for a broad perspective, first you have your basic electronics starting from how your components are made, which is semiconductors, right? Everyone knows about semiconductors.
Yes.
Yes, sir. Okay. So since you all know about semiconductors, or most of our electronic components start with something called semiconductors because semiconductor have very special property that can control the flow of electrons. Right. From semiconductors, we make basic components like resistors, capacitors, inductors, diodes, and most all of these are some of these are called passive components. Some of these all are active components which can store energy. Others cannot store energy. Then we make logic gates, and then from those logic gates, we make some analog circuits, right? Then from those apart from analog circuits, we can also make digital circuits, and that's it. Right, so the basics fundamental electronics just starts from your basic semiconductors. We just introduce all the components, also including BJT, and then we actually teach you to make some of the logic gates, how to make logic gates, and from those logic gates, how can we process signals? There are two types of signals: the digital signal or the analog signal. For digital signal, we will just combine logic gates into sequential circuits, right? And for analog signals, we can actually use something called as operational amplifiers and make circuits from there. And that's pretty much it. I think there's just some little bit of communication also involved there, basic in this particular course. So communication also involved there on how you can actually transmit signals without having distortions and over a long period of time, and how to make a transmitter and receiver. So I think everyone has gotten an overview of what you are about to learn. Okay. So, first of all, I would want you all to just have some very good idea about this stuff. So, if your basic is good, you have an interest, all of this would be very easy. Just something like it would be something very intuitive to you, right? You will just keep carrying this on, and only part that you would be stuck in is some question, some numerical that anyone could be stuck in. Okay, if you just made a small mistake, you just get stuck, and so on and so forth. So, do everyone know about digital signals or digital data, the 0 1 thing, right?
Not so deeply, sir.
Not very okay, sir. Okay, I will try to explain it. So there are two types of particular data here that we will be dealing with. One is our digital data. It they can take just two values. It's either 0 or 1. Okay. And most of the data that electronic circuits are dealing with is digital data. And then there is something called an analog data. The speciality of analog data is two specialities. First of all, it can take any values from 0 to anything, or even negative values. right? And it's continuous in time, right? Do you all know the significance of being continuous in time? So let me just ask you a nice question here. For instance, you all are sitting in a classroom, okay? And if you are all are sitting in a classroom, and I want to say I want to capture everything that happens in a classroom just for 1 second. How many of you think that it is possible? You can just unmute yourself. Okay, it's just a friendly conversation. I'm also your senior. I was a student. Actually, I just joined the college 3 years back, and I was somewhere where you were. Okay, so I'm not a professor. I will not just scold you or change your grades. It's just more of a junior senior interaction. So, how many of you think they can record just 1 second in its entirety uh, in a given classroom where you all are sitting?
by instant clicking of pictures.
Or just 1 second, Pranjal. 1 entire second. It's you can click a video, right?
Yes, sir.
So everybody agrees with that, right? That you can actually just make a video of 1 second and you can just capture everything that's happening inside of it. But that's not actually how it works. Like even if all of you are sitting in a particular classroom and I'm asking one of you to just capture 1 second in that classroom in its entirety, that's actually impossible. Why is that impossible? Is because analog signals are actually continuous in time domain itself. So if we see these graphs here, we can very easily see uh, that between 0 here and 2, there are actually just two values that this signal is taking, and the other values are just joined by a line. Right. So we actually assume that between that 0 second and 2 second, this is the path it's taken. But if we just get more deeper in this, let's say you all are sitting in a classroom, and between 0 second to 1 nanosecond, there must be something happening in the classroom, right? Even if you make a video, that video is just 30 frames per second. You probably had FPS in your cameras. Camera contain FPS, 30 FPS, 60 FPS, 120 FPS. Very good camera can come up to 1000 FPS, in which you just see very good slow mo. But it's not infinite frames per second. You can, because 1 second do contain infinite frames. So that's the problem with being continuous in time. If something is continuous in time, it's very, very difficult to actually capture it. No current electronic device can just capture 1 second in its entirety. So analog data that we refer to, like this given data here, is in analogous, right? That's not contain values between 0 and 1. This data is basically contains value between 0 to 80 and from 0 to 12 milliseconds. But actually what we are doing here is we are sampling in time. In 12 nanosecond, we actually sampled it in 4 places. Can everybody see? Where have we sampled it? Can anybody answer that? If I'm going too fast, if I'm just getting too off topic and you guys are not interested, you can just very easily say it. I will just keep teaching the tutorial. You guys can unmute yourself and just give me suggestions too. Like I think that giving a basic intuition and reasoning behind all of these things so that you can understand more of this deeply is good. But if you guys are saying that not right now, we just do that when we actually have physical tutorial in classroom, that's also okay with me. I can just start just solving all these questions and we can just move forward. So,
No, no, explain it.
okay. So here we can see we have sampled it in 4 places where at t equals to 0, right? And then at t equals to 2 millisecond, 8 millisecond, and 12 millisecond. We have sampled it 4 times and we just joint between 0 and 2, 2 and 8, 8 and 12. So we are basically averaging out. We are assuming that the signal was indeed increasing between 0 and 2 nanosecond, 2 millisecond. So this becomes an analog signal which is continuous in time domain, but is not a complete analog signal because it's actually impossible to get a real analog signal. So now you are understood how basically all of now you have understood how basically all of these signals work. So we will just start. Okay, first I think I've just missed one of the doubt that one student have asked. Yeah, regarding the circuit. So if we see a particular circuit here, what do you guys see actually in this circuit? A question, or do you guys see some sort of a problem or mathematical equation that you can make, or something else? Someone please unmute the mic and just tell it. What do you see actually when you see this problem? Who was the one who asked this question? Please unmute yourself.
Yes, sir.
So
Sir, your voice is not clear.
I was asking what's your name?
Supriya.
Okay. So Supriya, I was saying that if you see this type of question, what do you actually see? Do you see some sort of mathematical equation? Do you see some sort of a question?
Yes, sir. Equation of Kirchhoff's rule.
Okay, so that's something which we have to tackle, right? Before you see that Kirchhoff's law, before you see that one single KCL loop and KVL loop, and you have to just add up the voltages, you have to see something else, which is what's actually happening. You have to see there are two batteries of three batteries actually, two of 50 volts and one of unknown voltage. Right? Let's say we see three batteries, two of them are marked with 50 voltages, and one of them is not marked. Right? So, and we are seeing two resistors placed in front of us of 100 ohms and 200 ohms. And once we close the circuit, we can actually see that there is an electric field being set up in the wires, and the current starts to move. Do you guys all know that the energy actually does not move inside the wire? Does anybody know that? That's something bit off topic, but actually what happens is when you connect a circuit, the energy does not move inside the wire. There's something called pointing vector. You have all of have probably heard. The energy actually encircles the wire and just move outside of it as a field energy of the electric and magnetic field. So that's something it's very good to visualize. So you can actually see how the energy is being transmitted. Yeah, it's all around the wire. Yeah, the wire actually works as a waveguide to guide the waves. But wire does not contain the energy. There is nothing. The energy is not exactly going through the wire. It's just all around of it. The wire is just acting as a waveguide. So that's why when you place two wires very close to each other, they have something called capacitive effect or the inductive effect. And if you just put two conductors very close to each other, they can make a capacitor. If you just coil them around, they can make an inductor. Why? Because they have the energy flowing through them is not actually inside the wires. Because if it was inside the wires, that would be isolated. You just bending the wire would make no sense. Making two wires come close would have no effect. But that actually have effect. You probably would have studied in class 11 and 12. So after seeing all of that, we will just start to read the question then. That what now we can see the circuit, we can visualize the circuit. Now what is it? Now the approach that I generally follow while teaching tutorials is that I generally assess how much interest the student have. So generally coaching, so class 12, in class 12 there is a tendency to just spoon feed everyone that they will just give you a question, they will give you step by step solution, you have just to mug up the solution. There is no part of that that just comes up with brilliant idea, right? the Kirchhoff's law was before it was invented, it was actually used intuitively. No one actually knew what was Kirchhoff's law, voltage law, current law, but people, student and scholar actually used it out of sheer intuition. That okay, so current coming from here and here, and then this must be the voltage, and this must be the equality, and so on, right? So if they can do it, you guys can do it too, right? Obviously. But if from the coaching side you just spoon feed a lot of things, and then such thing happens that people just throw away their reasoning power, and they just want someone to just teach them by step, and they will just mug it up and use it to solve further questions. But that doesn't actually just sounds very good to me. Okay. So I will just give you a good intuition how to do it. And if you still face a problem, you can always message me. I will just share my number through your mail. You can always message me. Will just write the whole solution and just send it to you. Right. But what it does is just gives an opportunity for everyone to actually think about it, ponder about it. Okay. So is this thing okay, right? Does anyone have an objection with this?
Yeah.
Okay. Good. So here we can see there is a one mesh, and we can see the current flowing through it. And we know that there's just one unknown variable, right? V1. If we actually know what V1 is, then what would happen is that we would just know everything about the circuit. We would be able to know that since there was a 350 milliampere current flowing through the 100 ohm resistor, that there would be 350 into V is equals to IR times of voltage drop between C and B. And we know that the voltage difference between D and C is 50 volts, and D and E is 50 volts, and A and E is 500 milliampere into 200 ohm volts. Okay. And the finally voltage between A and B is V1 volts. If we know V1 voltage, we will know almost everything. Right. Okay. So the question asked here is calculate the potential between A, B, C, and E with respect to the point D, and find the value of voltage source V1. So what is some of the benefit that we have here is actually we have currents with us, the current that is flowing here. And since we have the current flowing here, we can do two things. Do you guys know about super mesh and super node?
No.
No. Okay, so
आज ही बनाया है।
पढ़ाया आज पढ़ाया।
हाँ भैया।
ओके, तो जैसे सुपर मेश और सुपर नोड में एक इंटरेस्टिंग कंसेप्ट क्या होता है, जैसे तुम लोग यहाँ देख पा रहे होगे, जो मेन आई थिंक प्रॉब्लम आ रही थी किसको, सुप्रिया को, वो आ रही होगी कि जैसे यहाँ 350 मिली एम्पेयर करंट है और केसी लगाने जा रहे थे, यहाँ 500 मिली एम्पेयर करंट आ गया, राइट? तो अगर कोई करंट और लगा रहा है तो ये प्रॉब्लम है कि एक ही लूप है, उसमें अलग अलग करंट जा रहे हैं। और वोल्टेज भी अगर हम केवीएल लगाते हैं तो एक आई वन ही करंट एज्यूम कर लेते हैं थ्रू दी कंप्लीट लूप, राइट? अगर हम एक सिंगल करंट अगर हम अज्यूम कर लेंगे तो इट वुड बी डिफिकल्ट कि ऐसा कैसे हो सकता है कि वही करंट 350 मिली एम्पेयर भी है, वही करंट 500 मिली एम्पेयर भी है। तो दिस करंट डिफरेंस सब समझ पा रहे हैं, आ कहाँ से रहा है? सबको ये नोड ए दिख रहा है, नोड ई दिख रहा है, नोड डी दिख रहा है, नोड सी दिख रहा है, ये लोग डॉटेड कनेक्शन है। तो डॉटेड कनेक्शन का मतलब है यहाँ से करंट आ भी सकता है, यहाँ से करंट जा भी सकता है, राइट? ठीक है, सो यहाँ से करंट आ भी सकता है, यहाँ से करंट जा भी सकता है। तो इसलिए हम लोग यहाँ से एक सिंगल करंट नहीं ले सकते कि एक सिंगल करंट जो यहाँ से आ रहा है उतना ही करंट यहाँ जाना चाहिए। ये हो सकता है यहाँ 350 मिली एम्पेयर आ रहा हो और ए से क्या नाम लेते हैं 150 मिली एम्पेयर करंट वापस यहाँ इंट्रोड्यूस हो रहा हो, तो 350 प्लस 150 मिली एम्पेयर 500 मिली एम्पेयर बन रहा हो। तो इसको करंट के टर्म्स में यूज करना हमको दिख रहा है कि उतना वाइबल नहीं है। तो हम लोग क्या करेंगे, वोल्टेज डिफरेंस के टर्म्स में यूज करेंगे। ऐसे वोल्टेज डिफरेंस हम लोग ने एक इक्वेशन वोल्टेज डिफरेंस की अच्छे से लिख लेंगे, जैसे सी और डी में 50 वोल्ट्स का डिफरेंस है, डी और ई में 50 वोल्ट्स का डिफरेंस है, और ई और ए में कितना 500 इंटू 200 ओम्स का डिफरेंस है, और बी और सी में 350 मिली एम्पेयर इंटू 100 ओम्स का डिफरेंस है, और ए और बी में कितना, V1 का डिफरेंस है। अब हम लोग को V1 निकालना है, तो बहुत सिंपली सबका आ जाएगा। V1 कैसे आएगा कि नेट वोल्टेज डिफरेंस इस मैच में कितना होना चाहिए, कितना होना चाहिए गाइस?
0.
0। परफेक्ट। तो सुप्रिया, अब आपको V1 पता चल जाएगा ना यहाँ पे?
Yes, yes.
ऐसा V1 आपको पता चल जाएगा क्योंकि आपको सारे वोल्टेजेस पता है इस लूप में, सारे रेजिस्टर के अक्रॉस और सारे करंट सोर्स के वोल्टेज सोर्स के अक्रॉस। आपको V1 भी पता चल जाएगा V1 है क्या। तो आपको एक बार V1 पता चल गया तो आप D को क्या करेंगे, रेफरेंस वोल्टेज मानेंगे, क्योंकि क्या लिखा है, विद रिस्पेक्ट टू, सॉरी, विद रिस्पेक्ट टू पॉइंट D, ये पूछा गया है यहाँ पे। तो विद रिस्पेक्ट टू पॉइंट D पूछा गया है, इसलिए क्या नाम लेते हैं, आप D को मान लेंगे एट 0 वोल्ट। ओके, तो ये कितना हो जाएगा, 50 वोल्ट्स। और ये कितना हो जाएगा, इन दोनों के बीच में डिफरेंस कितना है, 350 इंटू 100 वोल्ट्स, विच इज 3.5 वोल्ट्स, राइट? आई थिंक सो। अगर गलत है तो एक बार करेक्ट कर लेना है। 3.5 है, 35 वोल्ट है।
35 volt.
यस। सो अगर ये 35 वोल्ट है, तो अगर करंट ऐसे जा रहा है तो सी पे पोटेंशियल ज्यादा होना चाहिए, बी पे पोटेंशियल कम होना चाहिए, राइट? तभी करंट इस डायरेक्शन में जाएगा, लेफ्ट की तरफ। तो सी पे पोटेंशियल ज्यादा होगा तो सी पे क्या हो जाएगा, 50 वोल्ट्स। और बी पे पोटेंशियल आके कम हो गया, तो कितना कम होगा, 35 वोल्ट्स। तो यहाँ पे कितना आ जाएगा, 50 माइनस 35, विच इज 15 वोल्ट्स, राइट?
Hmm.
आ रहा है ना सबको समझ में? सबको समझ में आ रहा है? तो बी का हो जाएगा 15 वोल्ट्स। और ए पे कितना होगा, जितना हम लोग का V1 निकल के आया, राइट? सो ए वुड बी B प्लस V1। ओके, कूल। तो इस तरीके से ये पूरा क्वेश्चन तो आप लोग से आराम से हो जाएगा, क्योंकि इसमें कुछ खास है नहीं, बस आपको एक बार समझना है कि एक्चुअली है कैसे, इसको देखना कैसे। कि हम लोग को एक चीज देखना है, इसको करंट टर्म्स में देखना थोड़ा कंफ्यूजिंग है, क्योंकि करंट इसमें क्या नाम लेते हैं, नेट करंट इसमें जीरो नहीं निकलेगा, और हमको बाहर के सर्किट्स के बारे में नहीं पता है। हमको ये पता है कि एक लूप में वोल्टेज जीरो है, तो और सारी वोल्टेज दे रखी है, एक नहीं दे रखी है, तो उसके हिसाब से हम लोग इसको सॉल्व कर लेंगे। Cool। और असाइनमेंट में किसी को आगे दिक्कत हो तो वो मुझे एक बार मैसेज कर सकता है अभी, क्योंकि मैं ट्यूटर हूँ तो ट्यूटोरियल करना ज़रूरी है, इसलिए ट्यूटोरियल पे ज़्यादा फोकस रहेगा। ओके, तो ट्यूटोरियल में इस बार के टॉपिक्स क्या है, चार्जेस एंड करंट, सर्किट एलिमेंट्स, वोल्टेज, पावर, एनर्जी, ओम्स लॉ एंड किरचॉफ्स लॉ। तो आप लोगों ने अगर सुपर मैश सुपर नोड जो पढ़ा है वो यहाँ पे काम आएगा। आई थिंक आगे की तरफ कुछ क्वेश्चंस हैं, जैसे ये क्वेश्चन नंबर 8 सबको दिख रहा है?
Yes.
तो क्वेश्चन नंबर
यस
8 ट्राई करा, करा ट्राई किसी ने क्वेश्चन नंबर 8? तो क्वेश्चन नंबर 8 में आपको अब प्रॉब्लम क्या आएगी, जो आपको क्या लगेगा, सुपर मैश या सुपर नोड? सुपर मैश लगेगा ऑब्वियसली, क्योंकि मैश के बीच में करंट सोर्स आ रहा है। तो मैश के बीच में करंट सोर्स आ रहा होता है, तो उसमें प्रॉब्लम आती कहाँ पे है? वो ऐसा है कि जैसे आपको एक मैश दे रखा है और यहाँ पे एक करंट सोर्स है। सॉरी, थोड़ा इस पे आदत नहीं है मेरी एकदम, तो इसका थोड़ा, यहाँ करंट सोर्स दे रखा है जैसे 1 एम्पियर का, ठीक है? okay, okay, so I will keep explaining in English from now on. So we can see in this particular given example, we have two meshes. One has an current I2, one has current I3, and there is a current source between both of them. Since there is a current source between both of them, the main problem that we will actually get is when we are doing a mesh analysis, what we do is make two current sources, something like this. Just a minute. We make one loop here, and we make one loop here like this. Okay, so we make two KVL loops, and we try to just calculate the both of the KVL equation, and we just use the simultaneous equation to actually find the unknown variables, right? सब लोग ऐसे करते हैं, all of you guys do it like this. But problem with this, what the problem with this is, let us assume this as I1, let's assume this is I2, right? But since in this loop this is I1, right? In this I1 loops, this current is 1 ampere, So when we are writing the KVL equation, our I1 would come out to be 1 ampere, and I2 would similarly also come out to be 1 ampere, right? Just a sec. Or I2 would also be come out to be 1 ampere. It's actually pretty difficult to write with this, so bear with me. Yeah, I2 would also be come out to 1 ampere. But the problem with this node right here would be that this node is receiving 1 ampere current. But the the current leaving this node are also 1 ampere and 1 ampere. So this is basically something which just does not obey the law of conservation of charge, right? Do you all agree? Do you all agree with that? This is basically impossible. We cannot just directly apply KVL and just write 1 ampere and just move on. That's basically impossible, right?
Yes, sir.
So what we do actually to just avoid all of this is make a super mesh. And what is a super mesh? I will just explain it to you right now. Is that we just first of all understand that the current in I1 and I2 would just not be equal to the current in the middle source. So we started something like this. Let me draw a diagram. I hope it would be a neat one. Okay. So let's say these are the two loops and there is a current I1 flowing here and a current I2 flowing here. Right. So these are the two currents I1 and I2 flowing in these directions. So first of all, the first step for making a super mesh is removing the current source. So what we do is we actually remove this current source out of the picture. Okay. So then what happens is whatever elements are here, let's say there is one resistor, there is one battery, and then there is another resistor in this mesh. Then again, similarly, there is one resistor, one battery, and another resistor here. So what we do is we write a equation for I1. Uh, we write an equation for this whole mesh, but we just treat I1 and I2 as independent current sources. Something like this. Let's say this is resistor R1, this is R2, this is R3, and this is R4. Right. So the overall voltage equation would here be I1 R1 plus some current source voltage V0 plus, sorry, V minus I1 R2 minus I2 R3 I2 R3, and then there would be some another voltage was V1, and then at last this minus I2 R4 equal to 0. This is our final equation, right? So everybody understood how this equation was written. We considered I1 as independent source, independent current, and I2 as independent current. Now, when we solve this, how many unknown variable would we have? Can anybody answer? Yes, Vaishnavi, can you answer how many unknown variable would we have in this equation? Am I audible to everyone? Guys, you can actually speak up and just write. If you are correct or wrong, that doesn't really matter, right? You can just write anything. 5 unknown variables. So that's actually not precise. There are not actually five unknown variables. There are not actually six unknown variables because in general equations, our resistance general equations are for current and voltages only. In questions, the dynamic part is actually what's being asked. The static parts, resistance R1, R2 are already given. I have named them R1, R2, R3, R4. They are in the given circuit also. All of these are actually given. 2 ohm, 8 ohm, 4 ohm. Right. And the part that is not also the voltages are also given. 12 volt, 3 ampere, and this is actually a dependent voltage source. So then 3. That's actually not true. There are only two independent variables, two unknown variables here, which is I1 and I2. Yeah, two unknown variables only. I1 and I2, since we would know what resistance is, we would know how much the voltage source is. So the only thing that we need to know is the I1 and I2. If we found out I1, I2, we would actually solve this question number 8 given here. So to find the I1, I2, do you think we have enough equations? We just have one equation. There are two variables. So I don't think we have enough equations to solve this. So we actually need one more equation. So where would that one more equation come from? That would actually come from, let me show it to you, this particular node. Can everybody see? This particular node will actually give us what we need. At this particular node, what is happening? We have I2 coming inwards, plus 3 ampere coming inwards, and I3 going out. Right. Similarly, in this given figure, there was one particular current source earlier that we actually removed to make a super mesh. That was 1 ampere. So in that 1 ampere, we had I1 plus that 1 ampere, and the leaving current was I2. So now we have two equations for two unknown variables. Would everybody be able to solve it now? Yes, very good. Very good. So you can also unmute yourself and just write the same. That just now, since we already have two equations and there are just two unknown variables, we would be able to find what I2 and I1 and I2 are. And we would not actually fall into that trap of that since there is the current is just in the middle and if we just try to apply KVL, both current are coming out to the same. No, we don't do that. Actually, first remove the current and we make a super mesh and we just write an equation of the super mesh, and then what we do is just take another equation by including the middle current source, and that equation would be somewhat of this form, right, or this form, where we just have the all the defined currents with respect to the middle currents. Okay, so everybody is clear about super meshes, right? You guys would be able to solve most of the super mesh problems now. Okay, right. Guys, speak up so I would actually understand that you guys are understanding something, or I would have to change the way I'm teaching. If you guys do not give me feedback, I would know.
Understand. Okay, okay.
You did not understand, Swastik.
Understood बोला है समझ गया.
Okay, bhai, okay. So now next question is, have you all looked through this tutorial? Yeah, okay. As I'm now clear enough to practice more numericals. Good. So now what we'll do is we just go through all these questions and just see if you guys already understand it. Okay, so you can actually try it on. Okay, so question number 1, can you guys actually find all of these currents? T equals to 1 millisecond. Can you? This is basic class 10th, I think, class 11th mathematics. just need to find the equation of the line. Can you all find the equation of the line passing from 0, 0 to 80, 3? Yeah, 80, 3 it is right. Yeah. You'll be able to find this equation of the line, right? So if just till I would just try to explain it here. This point is 0, 0, and this point is 80, 2. Yeah. So if equation of the line is of the format y equals to mx plus c.
2,80.
Yeah. Yeah. Sorry.
2,80.
80. Correct. 2,80. So now since it's passing through the origin, so we know the c coefficient would be 0. Correct. And the equation of the line would just depend on its slope. So slope would be what? How the slope is calculated? y2 minus y1 upon x2 minus x1, right? Is it okay, guys?
Yes.
Okay. So now, since you all be able to find here what is actually the slope here, let me just also do a fast calculation. So 80 minus 0 is just 80. This is 80, right? I think so. 30 is being on it, is cross of 30. Okay. So if this is 80, 80 minus 0 is just 80, and then we have 2 minus 0 is 2. So slope is 40. So it's y equals to 40x. And what is y here? It's qt, right? Y is qt and x is t. Okay. So is it okay? So at t equals to 1 millisecond, so what would be charge entering here? If we put x is equals to 1. So what would y be? 40, right? So 40 millicoulomb would be the charge at 1 millisecond. And at 6 millisecond, we can see the equation of the line here would just be, because the slope here is evidently 0. So equation of the line would just be y equals 80, right? Across all of this. Am I right? Come on, guys. You just have given J examination. You guys would be actually very fluent in all of this. So all of this is just y equals to 80. And so similarly at t equals to 6 millisecond, the charge passing through a conductor would just be 80. At t equals to 10 millisecond, we just have to write equation of this line given here by the same y equals to mx plus c, and same using this slope. Here c would be the x-intercept, that is 12, right? So you just include the c, find out the slope, and you will have the equation of the line. Okay, so that problem is sorted. I think all of you would be able to do it. Yeah. If you guys have any doubt, you can just keep asking. Okay, I will just extend the tutorial class for 15-20 minutes. Okay. So I will take the attendance after this question. Okay. So the question is, the current through an element shown in the figure determine the total charge that has passed through the element at t equals to this. So what's the difference between the last and the current question is, in the last question they were asking, giving a particular point, and they were asking what was the charge at that point. So you just had to find the y value at this point. But now they are asking the total charge that has passed through the element. So we have to actually find the area under the curve from 0 to t, whatever t they have given. So from 0 to 1, you have to find the area under this curve, particular given here. So from 0 to t, the area under this curve here would be 10 into 1. That's just 10. Correct. So apart from that, the area under the curve from 0 to 3 seconds would be what? Can you guys answer? It's actually okay. So first of all, just let me take your attendance. That's more important here because if the class can actually end abruptly. Okay. Guys, just attend to your roll calls. Okay. So Ashish Chandra, present or not? Absent. Okay. Uh, Avya Chandra,
Present.
Aditya, Aditya. Okay. And Akash Srivastav,
Ajit sir.
present. Okay. And then Akhilesh Sahu, Akhilesh Sahu, absent. Okay. And then Akshit Taneja
Present sir.
and Anand.
Present, sir.
Okay.
Present, sir.
Okay. Then Ankit Das, Ankit Das, absent. And Apurv Raj,
Present sir.
Arnav Kumar, then Avinash.
Present sir.
Okay. And then Ayush Kumar Singh,
Present sir.
and then Gaurav Tiwari,
Present sir.
and Ishan Singh, and Krishna Gupta,
Present sir.
and Maitri Uppal, then Mudra Gupta, then Pranjay Soni, then,
Present sir.
okay, then Prachi Gautam,
Present, sir.
and Priyansh Raj. Oh, sorry, Prajwal Singh. Prajwal and Priyansh Raj, Priyanshu Kumar, Pulkit Singh,
Present, sir.
Rahul, Rajiv Kumar Pandey, Rishabh Arya, Rohan, Rohan, Rohan Kuntal, uh, S. Ruthik, Saket,
Present, sir. Shruti.
Satek Suman. Okay, then Samyak Kashyap. Okay, then Sangram Chakraborty.
Present sir.
Then Shashank Tripathi.
Present sir.
Then Shubham Ranjan.
Present.
Then Shrajan Sonkar. Shubham Singh.
Present, sir.
Okay, then Sudhanshu Kumar. then Sujit Kumar, then Sumit Sikarwar, then Supriya,
Present, sir.
then Suryansh Verma,
Present, sir.
Ujjwal Nayan,
Present, sir.
Utkarsh Kumar Yadav,
Present, sir.
Vaishnavi,
Present, sir.
Vidanshi Srivastav, Vishal,
Present, sir.
Yash, Yash, okay, Arnav, uh, Vimita Bhatia,
Present, sir.
okay, and Sambhavi,
Present, sir.
then Sashi Shekhar Mishra, Sashi Shekhar Mishra,
Sir, it's Sasi Kamal or Sasi Sekhar.
Sashi Shekhar,
Okay, I am Sasi Kamal.
okay, Swastik Mishra,
Present, sir.
Yashwardhan Chauhan, okay, thank you for joining everyone. And those all who have doubts, they can actually mail me on 22 EC 3025 @rjpt.ac.in. Okay, it would be shared over you, and you can actually mail all your doubts. Thank you everyone for joining.
Thank you.